Okay, Anna, the floor is yours.
Thank you, Christina. Well, thank you so much for having me today. Thank you and Giuseppe for the invitation. My name is Anna Beckman. I work in the agribusiness sector in the area of innovation and development in an agribusiness company in Argentina. I'm from Buenos Aires. It's the morning here, very beautiful day, by the way. Hope everyone is staying safe. And today I wanted to share with you how the new technologies are shaping it's actually all the industries, but specifically the agro industry. So I will try to show you all the examples about that. Please let me know if you have any questions. We will have a Q&A session at the end. So hope you enjoy it as much as I do. So let's see. First, a little background. Did you know that we are living right now the fourth industrial revolution? The first one was about water power, steam power, mechanization at the end of the 18th century. The second one was the Ford model, right? Where the mass production came, the assembly line, electricity came, that was end of 19th century and 20th century. The third one was in the 70s when computer and automation came. And nowadays we are living the fourth industrial revolution, which is the cyber physical systems. So let's see how this is changing the way industry is working. In traditional industry, everything was about mass production. Today, it's all about the personalization according to what the customers want. Traditionally, it was about large factories producing large amounts of stocks. Nowadays, there are smart factories which work with a more flexible production, a flexible schedule at a competitive cost. Traditionally, it was about planning according to stock, right? And then selling that stock. Today, everything is about the demand, and the production and the planning of the production is about the demand. And traditionally, it was all about cost minimization, and today it's about the return of capital employed maximization. So it's really fascinating how all the new technologies that we're going to see today are changing the way that industry works. And how does it look for agriculture industry? Well, this report from McKinsey from 2016 actually says that agriculture is in the worst state, or at least it was in 2016. It's the least digitized industry among the ones that McKinsey explored. So this is a little bit why we're here. And I think this report has really challenged the agriculture industry and has awakened the industry. And a lot of things have changed since then. So today, what I want to share with you, we're gonna see how this digitization process is shaping from manual systems to integrated systems, right? And to have integrated systems, we are gonna have this tech ecosystem, which are the enablers that allow us to live everything what we are seeing today. So today I'm going to explain what are all of these components of the tech ecosystem. And then we have some verticals that need to be taken into account. Facilitators, geospatial technologies, which are my favorites, and I think they are particularly useful for agriculture industry. And then the delivery platforms that are the ones that allow us to actually see and interact with everything we achieved in this process to arrive to integrated systems. So I hope don't get overwhelmed. It's gonna be a lot of information. My objective is that you get a sense of everything that is going on. And then if you have an interest in any specific topic, you can then go ahead and study that more thoroughly. First, we're gonna talk about the tech ecosystem, and we're gonna define these 5 components of the tech ecosystem. The reason I put this slide here is because I think these 5 components of the tech ecosystem are interrelated. So they all depend on the other to exist. So don't worry about the names. We're gonna explain each of them. And we're gonna start with Internet of Things. What is Internet of Things? Well, as the name says, it's a thing that has become connected to the internet, right? So I'm sure you have lots of examples of this at home. Maybe your watch that is telling you how many steps you made, or how did you sleep, or maybe at home you have a fridge that's telling you the shelf life of your products, or you can manage your lighting from your phone and change the colors. Well, that is Internet of Things. It works through sensors that detect and then communicate the data. And then that data is going to be available in a platform that integrates the information, that it probably do some analysis. And this, for the agriculture sector, is allowing us to trace the whole chain, which is an important issue for agriculture, especially with the demand from the consumer to have a more sustainable way of doing things. Traceability is the way that agriculture can explain how all the activities are done in a sustainable way. So let's see these examples. Here we have silo bags in La Pampa, Argentina. Silo bags are plastic bags that you put the grain there after the harvest until you decide to sell it. So nowadays, there are sensors that you can put there, but these sensors are now connected to the internet. So you can see remotely from the comfortable of your couch, what's the quality of that grain. And if that grain, let's say that the bag was broken and the grain is losing its quality. So nowadays you can see that remotely, and you can take decisions before it's too late. What about all the machinery? Machinery has advanced a lot. Today, companies are building Ferraris, right? They have the last sensors. Of course, they connect to the internet. So before, when you had a machinery that didn't connect to the internet, it was just a machinery. It was just a thing, right? Now they are connected to the internet. It's Internet of Things. So nowadays, the farmer, the producer can actually see how this machinery is working remotely. So this is a personal anecdote. One of the highlights of the pandemic for me, it was being in my couch in the winter and actually seeing in real time how one of our producers our farmers was harvesting, and I could see the speed, right? I could see all the indicators of how that harvest was being performed. That was really fun to see. Then, what else? Harvest. One second, I'm gonna have some water to breathe. Also, when you have some machinery that doesn't come with the sensors that you require, you can add that sensors. And we have companies like Acronex, who is adding sensors that, but for spraying machines, right? So you can see all the details of that spraying, and you can see that the spraying is being performed in a responsible way. And then cattle have, usually they have these tags, right? Well, today these tags are electronic. That means, that means that you can trace everything that that cattle is going through in the chain, and you can scan the electronic tag along the chain and see how was vaccinated, how if it has eaten. So this is very good for livestock management. And it's also helping to perform this traceability that we were talking about. So let's move on to big data. A lot of people are talking about big data, right? Well, big data in itself is just the act of collecting data, collecting large data sets. And today, data, it's the new oil, they say. So let me read you this quote real quick, and I think you're going to understand a little bit more. It says, data is just like crude. It's valuable, but if unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, etc., to create a valuable entity that drives profitable activity. So must data be broken down, analyzed for it to have value, right? So data in itself is not valuable. We need to do something with it. We need to clean it. We need to have reliable data. We need to have truthful data in order to create value. And then artificial intelligence, or AI, is going to come and process it. So afterwards, the users are going to be able to obtain relevant information. And that's why the users are going to want to share the information, like Waze, right? I share my data with Waze, where I'm at, if I have traffic or everything. And then Waze tells me what's the best way to go, what's the best way to go home. Same thing is happening with Netflix, Amazon, Spotify. They have developed new business models, right? Spotify knows me better than myself what I want to listen at specific times. So this is what big data is enabling. But this is not possible without artificial intelligence. So artificial intelligence is actually when machines convert the data into value, and they are able to differentiate patterns and trends. Machine learning is a type of AI, and it's when you have algorithms that actually learn from data. But as we said before, we need to feed it with reliable information. So the algorithm can learn properly. The algorithm can have our own biases. So it's important that the training process, that's how it's called, it's performed well. And then we can use it to classify and to predict. Classify meaning, okay, this is a pen and this is not a pen. And prediction meaning, okay, if this happened in the past, I can predict what's going to happen in the future. For example, if I know an example of banks and seguros. So when you get, so if I want to see if my client is going to give me, is going to pay back the money that I borrow, they usually see the behavior of people. They see if they study from the history, when did they give the money back, and what are all the inputs that say how that person is. And then you can predict if a person is similar to the one that gives you the money back or not. You can predict if that person is going to be a good customer or not. Let me show you some examples on agribusiness. So Zoom Agri is an Argentinian startup. It's located, it has offices everywhere. They recently opened one in Madrid. And they created this scanner that scans barley and other grains, but specifically for barley, they can identify the variety. So the different varieties tells you about the quality. And even though you can do it with the naked eye, of course, there are mistakes. So now with 5 minutes, you can perform this analysis instead of sending it to a lab and to do a genetic test. And and it really changed the way the whole chain works. So this is a great example. What about identification of plants? Everyone can download from their apps nowadays these apps that can identify plants, and the same goes for the farmers. Nowadays they can, well, identify plants, but of course disease. They can identify if it needs more water, if it's problems of nutrition. They can count how many plants. They can count the distance between the plants on the road, which is an important factor. And another example is spraying. So nowadays we have machines that they spray, but they do it selectively. So there is a camera that distinguishes the plant from the weed, and then it only applies the herbicide in the weed and not in the plant. And this is actually reducing up to 70% the use of herbicides. So that's pretty fascinating. So as you can see, artificial intelligence is giving us a lot of great examples, and every day there are new startups in the agribusiness sector, in the agtech and agri-food tech world that are being created, and new solutions are available. And here I want to do some parallelism between the GIKY pyramid, which is a pyramid of how wisdom is built. So basically, if we take data and we add some understanding to it, then it becomes information. If we organize and classify the information, we arrive to knowledge. And then if we add some reason to it, we obtain wisdom. Well, IBM is talking, or has, from a long time ago, is talking about this AI ladder, which is basically how from data we obtain wisdom. So first we perform some analytics, and then the next step would be to perform machine learning. Like, as I said before, machine learning is how the algorithms learn from the data, so then they can classify it or predict anything. And then we have AI, which is like to achieve the highest level in artificial intelligence, and you can do lots of things. There's neural networks, deep learning, lots of things. So let me share with you a personal example of the research I performed when I was doing my master's degree at UC Davis in California. So this image in the middle that you see, it's a satellite image from the Sentinel-2 satellite from the European Union. And what you see in the left are points. It's what we call ground truth data. So it's data that is collected, or in this case, I built it from 2 other maps existing from this area. And in this case, each point is indicating a type of crop, because that's what I wanted to study. I wanted to study what crop was it being grown in each of these pixels, right? So this image has 10 by 10. So each of the little spots right here is 10 by 10 meters in real life. So with this ground truth data set, I told the algorithm, okay, look, this point that corresponds to this point in the satellite, and the satellite comes with what is called 12 bands. It's, let's say, corn. Okay, so after the model has been trained, it can classify it. And then all the rest of the points that here are white were classified by the algorithm. And as you can see, we got an image that looks pretty close to the satellite imagery, but it has the information of all the crops. We have corn, we have alfalfa, grass. We can see clearly the water in blue. And what I like most about this tool is that you can see here the field boundaries, right? But the algorithm didn't know about them. So for me, this shows that this actually works because the classification was performed pixel by pixel independently. So this point right here was classified the same as the one that is next to it, and that happened independently. So I think that's really cool. So let's move on now to the cloud. What is the cloud? I'm sure all of you use the cloud and know what it is. Well, it's just the virtual availability of IT resources on demand. So before, companies needed to have infrastructure, right? They need to have their own physical servers. I remember when I was working in Syngenta, there was a whole room of physical servers, right? Well, nowadays, this information is kept in these, they are actually called server farms. Big companies like Microsoft and Google or Amazon have them, and they actually have server farms in different locations, so the information is backed up. So for companies, farmers and everyone, costs go down in storage, processing, security, and it's so easy to share, right? You put just right click, share, and then everyone or whomever you want can access. And this enables, I mean, you can access the information from any device. You don't need to have all of your information in your computer anymore. You don't need pen drives, right? I can work with this computer at home. I can go to the office and work with a different computer, and I will see exactly all of my stuff. So this is a great enabler. And last but not least, let's talk about wireless networks. This has changed the digital ecosystem, right? It's all about, we have different infrastructure, antennas, electromagnetic radiation, satellites, we have underwater fiber optic cables. And this is actually what it mixes the whole thing, right? Because it enables the communication between our sensors, the IoT, and the cloud. And then with all that information that we have big data, and we use that to perform artificial intelligence. And then we can have that information in real time. So let's see this example from the company Telesense from California. So they work with keeping or monitoring the grain quality in the post-harvest. So they put sensors in silo bags or in piles and bunkers or in silos, right? Here you have the IoT. Thanks to the cloud, this information is stored, and then they have a software that can process all of that, and in the palm of your hand, you can see how you can see the state of your grain. So let's do some recapitalization so far. Let's see where we are at. We talked about that we are moving from a manual to an integrated system. We discussed all the tech ecosystem that is actually enabling all of this to happen. And now we're going to talk about some facilitators that there are just some things that we need to take into consideration in order to arrive to this integrated system. So first, the standards. We need some rules and some conventions in the data that we have in order to enable the interoperability, because we want the information to match in format, so then we can actually make it interoperable. So this is a quick example. If I ask you where is this place, which is called Catriló, and it's in a little town in La Pampa, Argentina, you can say that the latitude is minus 36.41 and the longitude is minus 63.42. And another person can say, no, it's 36 degrees, 24 minutes, 36 seconds in the south, and west 63, 25, 12. Both people are going to be talking about the same, but one is going to be referring to decimal degrees and the other one to degrees, minutes, and seconds. And that for the system is a problem, right? So we need to define which of these are we going to use. Then we want the systems to be interconnected because we're going to have information in one system, we're going to have information in another system, and we want these systems to be able to talk. So the interconnection of systems facilitates the collection, the processing, and the communication of data. And for me, the most important part of this is that there are tons of platforms, and in agriculture, you have lots of platforms that can help you to manage all of your data from the field. And there's no system that can cover all the needs. So each system specializes in something different, right? So that's why we need the systems to be able to talk to one another. And that is achieved with the APIs, the application programming interfaces, which is how computer interfaces make that interaction between software. This is how softwares talk to each other. And I think nowadays all the companies have realized this, and it's happening that they are all open, right? So anyone, they all put their APIs available, and you can connect from different platforms. So that's really changing the mindset, right? And last but not least, and related to what we were just discussing, it's open data. This is a global trend, and it's allowing the democratization of information. In governments, it's allowing to show further transparency, right? Because governments are sharing their indicators, their management indicators. And what about the democratization of information in companies? So it used to be that companies have the information siloed, right? So in different silos, and there was no connection between them. But nowadays, they are building bridges between the silos, and the information is being integrated, and the information is being shared between different departments, and this allows for a better decision-making process because you have people with different mindsets that are seeing different things from the same file, from the same information. And actually, digitally native companies, like Google, they actually publish all the information because they want to retain its users, providing a better service to its customers. So it's the same thing as we were discussing Waze, or you can go to Google Maps and you can find anything you want. It's the same concept. The information is becoming more available to people, and that's an advantage. This is just a little example from the USDA of it's called a cropscape. So the same work that I did for my thesis, a lot of institutions do it, and they classify the crops. So anyone can go into this map right now and see for the whole US where are the crops located, and understand how each area is working, and you can do your own analysis. So that's really fascinating for me. So let's see where we're at. We talked about the tech ecosystem, we talked about facilitators, and now we're gonna go into my favorite part, which is the GIS Spatial technologies. Well, I hope you are having fun. I know it's a lot of information. This is the most nerd part. I hope you enjoy it. So let's see. I'm sure you all know what a GPS is, but do you know how it works? Well, it's a receiver, it's a signal receiver, and it can read the 30 satellites that are orbiting the Earth. And when it can receive the information from 4 satellites at the same time, it can triangulate it, and then it can know with a really high degree of accuracy the location, the speed, and the time from any receiving device. And actually, you have one in your pocket right now, and this is a big thing. So let me show you a little video of how Burger King took advantage of GPS to create a new business model.
The traffic jam Whopper. We used real-time data to detect our potential buyers in a traffic jam to offer them a Whopper and deliver on the move.
Fernanda, buenos días. Señor Eduardo, buenas tardes.
¡Ay, qué bello!
Llegaste en chinga, cabrón. Me cagaba de hambre.
Our media was 100% dynamic, promoting our service only in high congestion zones. By leveraging traffic and drivers' real-time data, we adjusted our billboards' location and content. The messages displayed information about the remaining time in traffic to order and personalized updates about deliveries in progress. Also, Waze banner ads and push notifications invited drivers to get a Whopper as soon as they entered our delivery zones. People were able to use voice commands to place the order and avoid tickets. Finally, using the latest Google Maps APIs, our app pinpointed vehicle location and speed in order to deliver for the first time ever to a driver on the move. The delivery zones changed following the traffic live, making our service available when a gridlock was identified, always within a 3-kilometer radius from the restaurants.
Hola Mariana, ¿cómo estás?
¡Ay, te agarraría besos!
Lo siento, estoy en servicio.
In just 1 week, we increased delivery orders by 63%, and our daily app download rate increased 44 times, becoming the #1 fast food app, surpassing McDonald's, Domino's, and Starbucks in Mexico. Coming soon, Los Angeles, San Paulo, and Shanghai. The Traffic Jam Whopper.
Enjoy the traffic jam.
So as you can see, GPSs are allowing a lot of fun things, right? So let's move on now to remote sensing, which is, for me, a very fascinating topic. The definition of remote sensing is super cute. It's just acquiring information about an object without touching it, without being in direct contact with it. And for that, they use sensors, which can be located in satellites, planes, or drones. And this acquires data of the soil coverage. And there's data that's visible for the human eye, and there is data that is invisible from the human eye, like near infrared, etc. And there are different resolutions. The most important two is spatial resolution. If the pixel is, let's say, 10 meters, of it's 1 kilometer, then you have less spatial resolution. And the temporality, how often the satellite goes through the same spot in the Earth. On the Earth. So this graph right here, don't worry about it. It's just to show you that we can identify the different features with, this is a spectral profile. So the light that is being reflected back, that's what the sensor measures. And you have different wavelengths. So if you see this profile of reflection versus the wavelengths, you are going to see that water has a specific type of profile, vegetation a different one, and soil a different one. So what can we do with this? We can identify type of crops and status. We can estimate agriculture areas and yields. We can make decisions about when is a good time to plant or harvest, identify pests, estimate soil humidity, detect nutrition deficiency. We can map the fields, lots of things. Cristina, please let me know if there are any messages that you want to share with me, or else we can talk about them at the end.
Sure.
I cannot read them right now.
Don't worry, I'll let you know.
Thank you. So this is an example. This is an image. And after we obtain this image and we analyze it, we can, for example, detect lower nitrogen levels versus higher nitrogen levels, or as I did in my thesis, we can classify and we can say, okay, this is water and the violet is maybe wheat and maybe this green is forest, I don't know, wherever the land is showing. And let's go to 3D scanning. 3D scanning uses a type of technology that is called LiDAR, which generates a cloud of points. This is the technology that autonomous cars use. So basically, it's sending this laser light to everywhere, and when it bounces back with a different object, then it knows that it has something there. So let me show you how this looks for plants. So this is a LiDAR scanning for individual plants. You can see there are 3 or 4 trees. And as I said, the laser emits light and it detects how long does it take to come back. And because it knows the velocity of the light, it knows the distance. And this is very useful for water management, for prevention of soil erosion, or for estimation of yields, because you can know the height of your crop and the whole shape. And now let's move on to GIS and spatial analysis, which is the last of these geospatial technologies that I wanted to share with you today. Geographic information systems are georeference databases, right? So if you have a database, let's say a spreadsheet, okay, this is like a spreadsheet, but it has, let's add 2 more columns, X, Y, for the coordinates, to make it very simple. And then you have this information presented on maps. And after that, you can perform what is called spatial analysis, which is based in statistical methods, and that can help you to find patterns, trends, and relationships within the data. And here there is an example. Oh,
Map.
Wait, here, this example, sorry. This example, it's a map that is showing where in blue, where is the soy, in purple, where is the corn, and it's showing different information for an agribusiness company. This is the most common software used for this are ArcGIS by Esri and QGIS, which is an open source software. And let me show you a little video that this company called Maptitude, the software is called Maptitude. It can explain why is this useful.
Maps can tell the story your spreadsheets can't.
Oh, the video has stopped. Let me play it
Every
again.
day you have to contend with vast amounts of data between your sales numbers, your customer records, your territory reports, and employee records. It's easy to get lost in the numbers. What you need is a way to find the trends and information hidden in the jumble of spreadsheets and databases you use every day, and to see the story that they are telling you. Maptitude mapping software unlocks the trends hidden in your data and gives you the tools to understand how geography affects your business and to visualize those hidden patterns. Know exactly where your customers are. See where sales are highest. Find over and underserved areas. And spot geographic trends. Maptitude also contains powerful location intelligence tools, giving you a deeper understanding of the geographic relationships in your data. Create pin maps by address, postal code, coordinate, and more for unlimited numbers of records and with all of your data attached. Create distance rings and estimate the demographic attributes of the rings. Determine drive time or distance rings at any specified interval. Build territories based on areas, proximity, or drive time. Filter features based on geographic queries. Determine trade areas and identify valuable sites. And identify hotspots.
So I hope you now have a better sense of what GIS and spatial analysis can do for businesses and for agriculture as well. And let's going further into the farmers and into the field, there's something called precision agriculture, right? Which is the concept of using the variability, the temporal and spatial variability of the field in order to apply the right input at the right place, at the right time, and in the right dose. This is something that in medicine has been used for a while. And it's basically stop seeing the fields as an homogeneous place and, putting the same inputs for the whole thing, and actually starting seeing it pixelated in different regions. It's called, in Spanish, is to ambientar, which is to make different, I don't know how to say it in English. So it's basically detecting different places and giving what that place needs in particular. This used to be only accessible for people that had access to these GIS softwares and that knew a lot about it. Nowadays, with all the software and apps and platforms available, every farmer can do it. If you know how to use the phone, you can do this. It's so easy, so intuitive. So this is a really game changer in agriculture. So let's see where we're at. We are one step away from having these integrated systems. And now we're going to discuss the last part, which is what are the delivery platforms and some concepts that we need to actually be able to leave all of this and actually apply it to our businesses and into the agriculture value chain. So let's talk a little bit about business intelligence, or BI, right? BI, there are a lot of softwares about BI, and they help you make decisions based on data instead of intuition. So sometimes people, they say, oh, I think that, I don't know, my land is very well suited for doing corn or to do wheat. And then after you actually see the data and you see the report in a BI platform, you say, oh, I thought it was suited for wheat, but it's not. So maybe I need to change to corn, or I need to change to livestock. So actually, through dashboards, through tables, and after they performed all the data management and all the analytics, we have these reporting tools. And nowadays you can see maps, you can see graphs, and you can see lots of things that actually make you, help you with the decision-making process. Collaborative networks. It's not about keeping your information to yourself anymore. It's all about exchanging information, exchanging ideas, interests through virtual communities and networks. And this is the democratization of information in place, right? So after you have detected the patterns and you have predicted the behaviors, you can actually act on it. And you can do it because just like Waze, you give information to obtain valuable information. Or actually, I should say, you give data to obtain valuable information. And there is a great example of this in California, the FBN, the Farmer Business Network, is a group of farmers that decided to share the information that each of them had about their fields. And they want to do farming more efficient, right? So they have integrated, they perform ag analytics, and now they have a better buying power. So these collaborative networks, of course, all the tools like social media and WhatsApp and Slack and Trello and all the collaborative tools are big enablers for this. And last but not least, I want to talk about the webs and the apps. Today, all these tools and the mobile devices are great enablers because you can have everything in the palm of your hand. But nowadays, the design is more intuitive, and even ERPs or your database management system that you use has become more intuitive. And that's thanks to, it's called UX and UI, so user experience and user interaction. So designers are really putting a lot of effort making the apps be intuitive, easy to use, and available for everyone. So this is what I say, that if you know how to use a phone, you can do precision agriculture. And this allows you to have all the information in one place, to do the decision-making in place in situ, and to actually understand how all of your inputs interconnect and help you to actually help you with your decision-making, right? So let's do a quick summary because I know it was a lot of information. So we started with manual systems with information in different silos. And in order to arrive to an integrated system, we are supporting ourselves in the tech ecosystem. We have devices that connect to the internet. We have a lot of data that is being collected. We have an artificial intelligence that can analyze this data and obtain patterns and obtain wisdom. We have a cloud that makes everything available, and we have wireless networks that allow us to have all of this interconnected. We have facilitators that allow us to make all of this happen and to have all the systems interconnected. The geospatial technologies are very useful for lots of industries, but I think that for agriculture is specifically useful because agriculture in itself is georeference. So all this information is helping farmers to make better decisions. And then we have delivery platforms, thanks to BI and intelligent reporting, and thanks to the collaborative network where farmers are sharing their information, and thanks to how easy it is to use the webs and the apps, we arrived to this model of integrated system and everything, and all this is all thanks to the digitization. So that's why digital transformation is such an important process for businesses nowadays. So let me end this with a very nice video that is going to show how this looks for agriculture.
Science and technology have taken us further than we ever thought possible, but there's much more ground to gain. Opportunity is everywhere. And to unlock it, we need to understand how all the factors that affect yield affect each other. We've never had more information at our fingertips or more power to enhance the way we farm. Because now, science allows us to bring vast amounts of data together to see the connections hiding in the code, to understand the relationships between the soil, the field, and the atmosphere for every unique environment. So we can see things we've never seen and know things we've never known. So we can tap more of the potential in every seed, every acre, and every dollar we invest. and use a new level of precision in the pursuit of higher yields. The Climate Corporation is building more than innovative products. We're building an ecosystem of ag technologies that integrate, that enhance each other, that transform the future of farming. Introducing Climate Field View.
Okay, folks, so this was everything for today. Here is a quick summary of the model I used, which is based in a very nice report by the GeoBuoys community. Here are all the videos that I have used, and thank you so much for your attention. And now we can move on to the Q&A.
Thank you, Anna, for sharing with us all this interesting information. I don't know if you're available to check on the chat, or you want me to read the questions. How do you want to do it?
I can read them. Let's see.
Okay, perfect.
Yeah, I probably talk like someone in Uruguay, Pablo. Anna, have you been able to apply this technology to agriculture mechanization, for example, determine use per hectare, amount of fuel used, route of each tool attached to the tractor, seeder, combine, etc.? Well, I'm not an expert in this, Pablo, but all the companies from John Deere and all these companies, they are putting really a lot of effort in this. And as I said before, they are Ferraris. They come with amazing technology, great sensors. Sometimes they have their own platforms. Now they are connecting to different platforms. So you can actually determine lots of stuff. I think that, I don't know if there is a sensor specifically for fuel, but you can basically, everything that a machine has, if it has a sensor, you are able to analyze that and to make better decisions. I hope that answers your question. Have you been able to apply this technology? Oh, this one we already read. Agricultura en ambientes. Yes, I don't know how to say that in English. If someone knows, please let me know. Hi, thanks for this great presentation. I teach over 1,000 agri students, mainly for developing countries. Can this technology good for small farms? Yes, this technology is great for any size of farms. As I said, there are a lot of platforms that you can use from phones. Depending on the country where you're at, you can find different tools, but basically, even if you have connectivity issues, which is a big problem right now everywhere, usually you can connect to the internet at home, you can download the information there, and then when you go to the field, you can work offline. And then when you come back, maybe you took pictures, maybe you took some georeference points, and then when you come back, you can see everything. And you can analyze the data. Lucas, thank you, Lucas. I would like to know, where do you see that farmers have the biggest barriers to move to this kind of agriculture? Well, I think there are two big barriers. The first one is connectivity. The infrastructure needs to be better, and with time, connectivity issues are going to be solved. And the second one is generational, right? So people that are not really used to these kind of tools, it's harder for them to understand. But thanks to all the UX and UI, and that apps now are really intuitive, it's even more simple. And I'm working with a lot of producers that, you know, from people that only know how to use a phone and they think they cannot do ambientation, if that's a word in English, in their fields, and they are able to do it. And I'm also working with people that are really knowledgeable in geospatial technologies, and it was hard for them to understand these tools because it's a different way of thinking it, more simple, and they are also doing it. So I think it's a matter of time, and the pandemic has really allowed and has really pushed all of this, because people in Argentina, people couldn't get to their fields, so then they started to see what they had available online.
So there's a huge space for the UX students to go there and explore on how to develop some interesting tools to fight with this barrier of the generational, let's say, fear to get involved with the technologies, with the new technologies.
Yes, this is just like when you help your grandparents with technology, same thing for this. And also the universities, you know, and institutions like the BTS, it's really helping, right, to achieve this, because the traditional schools are, maybe they are adding some of this information, but not enough, and then you need to study, you know, the core of let's say chemistry in my case, or agriculture, but then you go outside of the school and then you find all of these technologies, and every time it's easier to use. So I think it's just a matter of time until people really know how to use all of this. Thank you, Saman. Thank you, Pablo. Cyril, do you know what percentage of farmers have integrated to tool system like this in the United States, in Europe? I don't have a number. I think I can talk a little more about Argentina, and I think the number is really, really low, maybe 5%. If it's 10%, it would be a lot. I think there's a huge, huge opportunity and a large way to go. Do you think the use of 5G towers will help improve connectivity so farmers can get access to these tool systems? I'm not super familiar with 5G towers in particular and how they work, but my understanding is that they bring more connectivity. So if that is the case, then yes, it should help everything. That all the investments in connectivity will help farmers to advance. Pablo, do you use ArcGIS for your work? Yes, sometimes I do. I also use QGIS, environmental agriculture. Thank you, Pablo. Yes, ArcGIS and QGIS are great tools. They are hard. I mean, you need some time to understand them, but the amount of analysis that you can perform is truly amazing. It's a fascinating world to go into. So I really recommend, if you're interested in these geospatial tools, that you do some study on that. Thank you, Pablo.
Okay, I think we are done with questions. Thank you, Anna, again for being with us. Thank you all the participants that were connected with us. Stay connected, because we'll have all Fridays interesting guests sharing their knowledge and their experience in this amazing and involvement technology field. Oh, I think we have another question here. Let me see. Oh no, it's just a thank you, Anna. Very interesting.
Thank you, Philip. I hope you enjoyed it, and you can contact me through LinkedIn if you have further questions.
Okay, thank you.